Hello everyone. In this video I'm going to talk about how a non-displaced file is constructed. In other words, it is called board class in place files. This is the first step of file construction. First we have to setting out the file location. This is done by a license surveyor using a total station or some kind of machine, GPS machine, and we had to mark the accurate location according to a survey. After that, we need to take the time measurements of the file location, because once the soil excavation is started, the center point which we have already marked is cannot be found. So we had to take time measurements of that center location, and then we can use that time measurements after after the construction started. We can check using that time measurements, because once first we excavate using the file boring machine, then we have insert the steel casing. That when inserting the steel casing, we cannot use that center location. So we had to use the time measurements to check the casing location. So this is the second step. Then this is also a very important step, because when we are doing file excavation, the file boring machine should be very stable, so that we had to prepare the ground and use a steel plate near the file excavation to locate the machine. In this video, I'm using three construction sites, file constructions, to give you the examples of how those three sites they have constructed the file. This is a one site. They are going to start the file excavation using file boring machine. When the first excavation, we should be careful about the exact location that we use file excavation bucket, because the first step is to locate the machine in correct place. For that, they are using the time measurement as per the video, and this bucket is called short flight clay auger, and there is some other buckets also where we are using them in next stages, and this is the first bucket they are using. And also, when another thing is, we had also check the file location and the verticality of the machine, because if the machine's arm is not vertical, then file when it's going into deep, the files is not according to the verticality is not correct. So we have to check the file machines verticality also. So this is how they are getting out the soil using this bucket. Normally this process is going up to 10 meters likewise, but this can be changed according to the site. This is the first step of excavation, because after sometimes we will be using steel casing of 10 meter or 15 meter or likewise. According to that steel casing length, we had to excavate the file as a first step, because then we had to insert that steel casing into the file hole, and for the inserting of that steel case, we are doing this first excavation step. And this soil is stacked in near place using same machine, and this is the steel casing that I have told you before. We had to place this steel casing inside the pile, and when placing this steel casing, we had to check the correct position and the verticality of the steel casing, because this will cause defect file if we did not check the correct location and correct verticality. And this steel casing length will be vary according to their method, but generally this type of steel casing is used in first stage, because this steel casing usage is to avoid the collapsing of the soil in between in around the pile, because if we didn't use a steel casing in pile construction, the soil will be collapsed into the pile, because in top layer we are machinery is moving, some heavy vibrations can be happen. Then to avoid soil collapsing, we use this steel casing up to certain length. Some piles they are using permanent casing, but this time I'm going to show you the not the permanent casing. These are steel casing used only in excavation, and they are removed before completing. And in this side they have used some higher length steel casing, and these steel casings are inserted to the board pile hole using cranes, and sometimes the pile machine itself, they are using the pile machine to insert this steel casing. And this is how they have this side they have used crane to the insert steel casing, because this steel casing is a little bit higher in the length. And in here also they are using time measurements to check the location, because if we know the center location, then we can calculate the casing diameter. As example, we take 100,000 millimeter casing, then we can deduct that 1000 millimeter casing, we can divide that 1000 millimeter into half, and take the 500 millimeter and deduct it from the time measurement. Then we can get the measurement up to the casing external face. Using that time measurement, we have to check the location and insert the casing, and also we have to check the verticality of the casing. Otherwise, when it's gone too deep, the verticality will be different from not according to the setting. And this is the 3D animation of how a pile is constructed. In this you can see a cross section of the board pile. Here they are here it is the same pile machine is used to insert the steel casing. In this video they are using a full steel casing up to the bottom by connecting each casing, but in normally not every side they are using full steel casing up to top to bottom, only top area up to 10 meter. Likewise they are using steel casing. In this side the steel casing height is long steel casing, therefore they are using special kind of machinery to hammer the casing into the ground. If small height casing, we can use the pile boring machine or excavator or some kind of machinery to insert the casing, but here they are using hammer. hydraulic or hammer. So as you know, in this piling we have our first challenge is soil collapsing from top. We have avoid that by using a steel casing, and our next challenge we are going to facing is edge collapsing from the bottom of casing after casing ends. there will be also soil collapsing occurs. So in such occasion, this is happen due to the HROG pressure. So we are using water with bentonite. We have some it is called bentonite. We use that bentonite, some kind of soil, and we are mix that soil with the water, and we have fill our pile hole with that water, with bentonite water. So the density of bentonite is higher. So because of the pressure of the bentonite inside the borehole, the bentonite goes inside to the soil skeleton. So the soil edge collapsing, soil collapsing will be avoided due to this bentonite pressure. After steel case inserting, normally in here also you will see they have prepare the top surface, removing soil and other things, and they are placing some sort of a steel square steel like something to pond around the pile. Use of that is to avoid that bentonite water goes out from the pile side. So using that bentonite, they have I'll tell you it at the exact location. You see this is still, and here they are inserting the steel casing. So next, now we are starting to excavate the pile using our bucket, organic bucket. So now this is what I call steel square type thing. We have placed this near this pile, and we fill with the bentonite water. This is muddy water, it's called bentonite, and using this usage of this bentonite is to avoid the soil collapsing, edge collapsing inside the pile. Due to this pressure of bentonite, this soil collapsing will be stopped. And then there is another small thing to say, because this bentonite is using this bentonite, we have fill and flush the pile. So that water coming out of the pile and pump again to the bentonite water tank and filter and resupply to the pile like a circle. They have from until the pile excavation end, this bentonite is using oftenly, and otherwise this pile will be collapsed. This is how they are preparing the ground to avoid the water is go other areas. Using this bentonite is called bentonite impregmentation. So therefore, because of this, the soil will get bentonite stabilization. This is due to this usage is to prevent soil collapsing. And until our next target is to find the weather drop. Whether if you know, there is in our earth, there is first we are finding the weather drop. This is when we are excavating, we have to time check the excavating depth. So in likewise, once we find the weather drop, we can identify that by our uh, our pile excavation machine, there is an arm called caliber. The caliber is turning roughly. If there is a soil excavation, it is normally the sound is different, but once it finds the weathered rock, the sound is different. And another thing is, while we are excavating, time to time we are checking the Brentonite viscosity test. Likewise, we have some tests to do. I will explain those tests in another video. I have put the test just for your reference, and this I will explain it in very much detail in another video. But just to know, this test are also doing. Then until while you are watching this test, I'll say our next step. Now what I'm saying is, we have to find the weathered rock. We can identify that by our caliber. Our boring machine caliber is rough turning, so we can identify that we have found the weathered rock. And also time to time we are taking samples from our excavated earth and check if there is any rock particles. Likewise, when we hit the weathered rock, we can identify small weathered rock particles. The weathered rock means it can crush with small load. We can just hit one stone to another and check this is the weathered rock inside, and we can identify now we have find the weathered rock. After finding the weathered rock, we had to by 300 millimeter we had to check the rock samples until we find the hard rock. Normally in our when we start the rock socketing, we are changing the soil excavation bucket to rock excavation bucket, and normally there is first we are finding weathered rock, and then the time to time the rock will get hardened. So normally weathered rock will excavate 2 to 3 meters per hour, but once 1 to 1.5 meters per hour, but once it found the hard rock, it will be 500 millimeters per hour. So according to design and engineers recommendations and all, you had to rock boring. This is the rock samples, and here we once we have find the hard rock, that is the point we are going to calculate the actual rock socketing length as per engineer's recommendation. If engineer required us to excavate rock for 1 meter or 1.5 meter in hard rock, we are using that point as a starting point. First we hit the hard rock, that is the starting point of our rock socketing, and from that starting point to 1.5 meter or 1 meter or whatever the engineer required, we will start rock socketing. So this is very important, because rock socketing is very high costly thing. So normally this is the place where so many misunderstanding can occur between contractor and the client and the consultant. So we had to monitor the exact rock socketing length, and time to time we had to take the samples and check. This is once we found the rock socketing, and once we end the rock socketing, our excavation part is mostly over. Next one is we had to do the pile flushing again with the Brentonite, so to clean the mud and soil particles inside the pile and ready for the concreting. pile depth using tape. End of the tape they have some heavy steel knob, and putting that inside the pile and check the pile length. While with the bentonite they are using some polymer particles to do the same thing as bentonite. This is the bucket using for the soil collecting. This is what they are looking for, the samples, rock particles. So we can identify that they have found the weathered rock. So they are changing the rock socketing bucket, the normal soil excavation bucket, to the rock socketing bucket, rock excavation bucket. This machine's arm called the caliber. This is like antenna, goes down to the depth. When rock socketing, there is diamond cuts in the bottom of that bucket, so that using the diamond cuts the rock keeps getting excavated. Here also they have again checked the depth. So these are the buckets that we have used in our file extraction machine. These are the diamond cuts that we use in rock excavation. Now on this side they are using that bucket to start the rock excavation. So after the file excavation ends, we are putting a pipe called trim pipe. This is a steel pipe, can interlock one to another, and put this up to below to the bottom of the pile, and these steel pipes are called trim pipes. These are, after we put until the bottom, from the top of the trim pipe we are fixing pump, and we flush the pile for 1 hour or 1.5 hours to clean the pile and ready for the concreting. And then here now they are preparing steel cage. This is the reinforcement what we are using the pile. This is the high diameter bars, 20, 25, 30 like bars are vertical bars, and we are also using spirals like stirrups in the normal columns. Here we using spirals, and we lift the cage, this steel cage, using cranes, and put this cage into our excavated pile. Before we are inserting this cage, we are removing those trim pipes, and we insert this cage. When we are inserting this cage, sometimes normally steel bars comes 6 meter, 12 meter likewise. Most time we are for piling we are using 12 meter bars, but if the pile depth is more than 12 meter, then we have to weld two steel cages one to another. So that is done by, first we are putting the first cage, and then we inserting second cage to top of that cage, and weld those two cages one to another, and we are putting total cage down. Likewise, if we need another cage, we can weld it to top of that second cage. And when inserting steel cage, we have to use that covering blocks, like circle covering blocks. This will easy for the steel cage to go inside the soil. And the challenges we can found in inserting steel cage is if until that after we clean up the file, and before we enter in the steel cage, if soil collapse, the steel cage will stuck in without going into the pile. Then we have some challenges. We have to carefully clean before inserting cage, and we should insert this cage vertically. If this hit in the wall of the pile, the pile soil could be collapsed. So then we are facing the problem. So carefully we should insert the steel cage. and sometimes we using excavator to push the cage if some stuck, and then after finishing the inserting the soil cage, again we had to do some washing using trimmy pipes. Anyway, we had to insert the trimmy pipes until to the bottom, and we wash the pile again 1.5 hours, and another thing is, in steel cage every joint should be welded. Because not like normal column constructions, we had to weld all the joints, because this steel cage should have enough strength to lift and move likewise. The piles are constructing variety of diameters: 1000 millimeters, 800 millimeters, 1200 millimeters, 1005 millimeters. This is divided according to the structural design, and the load of the building and the soil bearing capacity. Steel cage. We are also influshing the pile, so because we had to remove all the rock and mud particles from the bottom of the pile, so that bentonite is we are using as a circle. After we are inserting the bentonite to the trim pipe from the top of the trim pipe, it goes to the bottom of the pile and flush the pile bottom and comes out of the pile, and then we again collect that bentonite water and send that to the desanding machine, and it will filter the sand, and again it will send to the bentonite sump, and from bentonite sump again it pump top of the trim pipe. Likewise, as a circle, it will flush the pile up to 1 hour, 1.5 hours before concreting. Then we remove that pump from the top of the trim pipe, and we ready that trim pipe to the concreting by fixing a concrete bucket on top of the trim pipe. That is cylindrical bucket. This is how they are removing the top part of the trim pipe and fixing that bucket. And again, this is the pump that used for the used bentonite water and send it to the desanding machine. This is the end flushing. Top of the trim pipe, they are putting the, before concreting, they are putting the bentonite and collect that used bentonite from that side tank, side pump, and again same circle is going. So this is the fixing ready trim pipe for the concreting. And finally also we are testing the bentonite sample, because if the pile is correctly flushed, that we can check that from bentonite, because this from variety of tests they check the how much of sand particles, soil particles are inside the bentonite water. So this is just to, I will explain this test in later video, but this is just they are calculating the time that it take to penetrate that known amount of water, so we can check the density of the bentonite. So here they are putting the concrete to that top bucket, and in here we cannot use poker vibrators in normal concreting, so we are using the same trim pipe to as a poker vibrator. Using cranes, we are lift the trim pipe and shake that trim pipe while we are doing concreting, so that will act as a vibrator for the correct concreting. And before concreting, normally we had to do some test tubes and other concrete testings. We are not using normal concrete. For the piling, we are using special piling concrete, special mixer. Normally this water content is higher than the normal concrete, because the concrete should easily goes through the trim pipe up to the bottom until the concrete flushed from the top of the pipe. normally in piling concrete wastage is a little bit high, because until that bottom part of the concrete bottom part is mixed with the muddy. First concrete bucket we are putting into the pile is mixed with the mud, and this first concrete part is comes out of the pile when concrete flushing. So that until that muddy concrete is coming out of the pile, we had to fill the concrete from the trim pipe, and some concrete content will be wastage, but this is how a pile done. And top anyway up to 1 meter or 500 millimeter, we have to break the top concreting of the pile to remove the loosened concrete particles. While concreting also, once that bottom part's concrete is done, we are removing top part of the trim pipe and again fix the concreting bucket to that below trim pipe. Likewise, until the concreting filled up to bottom to up to top, we have to remove one by one trim pipes until it because we cannot remove all the trim pipe in once after concreting filled, because of the concrete load. We had to remove one by one while filling the concrete, but always the end of the trim pipe should inside the existing concrete layer. We are not lifting the trim pipe from bottom and bottom out of the concrete layer. Then if we lift out of the concrete layer, there will be a sandwich muddy concrete layer in between the pile. Then that pile load bearing capacity will be low. So we are not getting fully out of the concrete layer in bottom of the pile, but we by time to time we calculate the filling height and remove the trim pipes from the tops. Normally trim pipes are interconnecting one to another, so top of the trim pipes are 1 meter, 2 meter, likewise end of the trim pipes are higher 3 meter, likewise. Normally when we are ending the concrete, with time to time we have to check how much volume we need concrete for the filling of the pile, because we cannot exactly calculate the concrete volume need for the pile, because inside the ground there will be a not exact size cylinder. There will be some bulk areas in between pile. When we if pile is 30 meter, below 20 meter, likewise there will be a bulk area, so we cannot exactly calculate the concrete volume. After some trucks are finished, we measure the height of the cylinder and order the our balanced concrete quantity as per our measurement. Here they are removing one of the trim pipes from top. every time when we lift the trim pipe, we have to lock the trim pipe from the mouth of the pile casing, because once we disattach the trim pipe from the crane, the trim pipe could go inside to the pile, then we will face big problem. So we will lock the trim pipe from pile mouth and avoid the trim pipe goes into the pile. Here they have removed the top trim pipes and fixed the bucket into the bottom one, and again start the concreting. Likewise, this process is continuous. Here they have up down the trim pipes for the pokering purpose. Here the concrete is fashioned from the top of the pile. The fashioned concrete is the first concrete volume we have put, and this is mixed with the mud and oil. So we had to put some concrete until the mostly mud concrete comes out of the pile. After the concreting finish, here you see we are removing the steel casing, because we are not using this steel casing as a permanent casing. Sometimes we using permanent casing, but this type kind of steel casings are not permanent casing, they are just for the concrete purpose. After concrete finish, we are lift the concrete casing and if we are using permanent casing, most of the time we are not using this kind of a very hard steel casing, because this casing is very much costly. So this type of hard casings are used for the temporary avoid the collapsing of soil. And after the concreting finish, we remove these casings. Here they have used some extra concrete to top up the top of the concrete. This is side to side, this could be changed, because this you as you remember, this casing is very lengthy. So due to that, they have used some balanced concrete to fill up the casing bottom if some settlement happen. Yeah, I have selected 3 sides because to show you the differences between each side, how they are doing the things. Here I have told you earlier that they have to lock the trim pipe while removing top trim pipes. Here they are removing top trim pipes. This is the animation of how concrete is filled. The top layer is muddy concrete. Here also they removed the steel casing. Here they are doing the concrete testings. I will do another video for these testings. Another thing, when we prepare this test cube, we have to number the test cubes as per the truck and volume, and because if there is any fault in the concrete, we should identify which area, which concrete volume that it happened in top layer or bottom layer or middle concrete. Then we can take a decision about the pile. This is the pile hacking. As I told you before, the top muddy concrete layer we had to remove up to 1 meter, 1 meter depth. This is called pile hacking, and this is the testing of the pile. And this test also, this is called pile integrity test, and this is using by small hammer. They can take the total pile situation, what is the loading capacity likewise, and another test also we are doing for the test to pile strength. So I hope you all understand this piling process, in situ piling process, and my English is not very good, so if you have problem in understanding, I'm very sorry. I'll try to make my best, and I hope you will understand something from my video, and please subscribe my channel and press the bell icon for the upcoming videos. I hope this is my first video in my content Surveyor channel, and I hope to do videos like this for you in future also. All for the professionals in the construction industry, and these videos I have done by my experience, but I have gained in my professional live, and this is very I'm very okay with the, if there is wrong, you can comment in my video, then I can correct them in future videos. And I request you all to subscribe my channel and press the bell icon. Thank you. We will meet in next video. Thank you.